Let's recreate our example. Let's say we have some sort of long L and we store a value in here. And then let's say we have an int x and we want to store the value of the long in there. As you can see, we get a compile error. Why? Well, long is potentially too big to be stored into an integer. In this case, I'm sure it will fit, so I'm going to cast it to an int. And as you can see, the red squigglies goes away and it looks good like this. We could do something similar with double and a float. So remember, the double is bigger and more precise. So let's just store some sort of value in a double. And actually, this will also fit in a float. So I want to do this, but I cannot say this because a double might not fit into a float. What I can do, I can cast it to a float. And then IntelliJ is happy again. So what happens if I try to do this, but actually it doesn't fit? Remember that char was an unsigned variable. It cannot be negative. So let's just create some sort of, I don't know, a byte b. And let's store negative 23 in there. And then I have a char c, and I want to store the value of my byte b. Well, in that case, I need to cast it to a char. Then if I cast it to a char, it will compile just fine. But will this run just fine? Well, let's run it and then find out. So let's talk about the funny thing that's happening here. Why does this work? Well, this has a bit to do with the way Java is working. Java mandates that any of the arithmetic operations on the primitive types is not going to either overflow or underflow. So what's happening here is it's actually being changed into a rather big number. So stay with me when I'm going to do the next conversion here. So well, if I were to print this is not going to be very helpful, but let me show you what this does. As you can see, it shows an arrow pointing to the left. But actually, I'm going to be helped more with the numeric value. That's going to explain it a bit more to us as well. So instead of doing what we're having right here, I'm going to say int I, and I'm going to assign the value of c to it. And then I'm going to print the value of I. You can see the numeric representation of a char. And you can see that, in fact, it's a really big number. So we try to assign negative 23 to it. And then what happened is that it turned into a really big number. This is because it doesn't allow us to have an overflow. So instead, it goes to the maximum value and starts from there. So just to make sure that this is still clear. So the maximum value of a char would be 65,535. So in here, if we were to add 1 to it, we would now get 0 instead. And this is because the char will not overflow. Instead, it will just go to the other end and continue from there. So this is going to be a problem though, and this is very funny because it's related to casting. So it says require type char provided an int. Well, this operation, it's an int. So instead I'm going to cast it to a char, but I need to put this between parentheses in order to cast the outcome of this to a char. After that, I'm going to print the value of the new char. And as you can see, this is not very helpful again. So instead, let's go ahead and cast it to an int. And now you can see it's 0. So if we're for a primitive at its very maximum, and we try to do an addition that exceeds its maximum, it's going to go to the smallest value and proceed from there. Likewise, if we're at its very minimum, and we try to deduct even more from there, it's going to go to the very end and continue from there. As you can imagine, when they created bank accounts in Java, they did not work with primitives to hold the balance of your account. Let's say unfortunately. We have seen how we can change the type of a value using casting, and that we need to be very, very careful with doing this in order to avoid unexpected surprises. In the next video, we're dealing with another exciting topic: how to store multiple values in one variable with the use of arrays.